Okay, there we go. Still setting up. This was kind of impromptu, so forgive me while I spend about 30 seconds finishing the setup. $30. There we go. Okay, there we go. Okay. So the agenda has changed a little. Actually, hold on one second. Okay. Let's see if this thing is working properly. Yep, working perfectly fine. There's a ton of warnings, but that's fine. I know what they're about. So this is Unity. We're not at Unity 6 quite yet, but I intend to work in a Unity 6 workspace. That's the idea. Give me 1 second. So I'm working with another fellow on the design for. All right, so let's start from the top. The other project, what I consider my main project, is I'm going to put that on the back burner for a second. I want to finish. This is kind of my redemption arc when it comes to game development. So that main project is not going to be done, I mean, at the pace that I was going at, probably for another well, it depends. If I develop it in Unity, I could probably get it done in 6 months. But in Godot, it was going to take maybe another 9 months before it got to a place where I was in Unity pretty quickly. That's actually part of the influence of the reason why I decided to go with Unity on this. Give me 1 second. Yeah. Just making sure that, because some of the settings are a little bit weird. Gotta just double check certain things. Knowing my luck, right? Can I not manage? That sucks. Okay. I'm going to open Studio real quick. So if you have the reason why, if Apricot, if you're on the, looks like you're on. So if you're on, I would think it's better to communicate via the YouTube instead of communicating via Discord, because there's a time delay, and you know, last time that we did this, I was going over stuff maybe a little bit too fast, and it's just, this is better, I think. If it's not, let me know, then we can just do it over Discord. Well, not the streaming stuff. Streaming is absolutely, between your connection and my connection, things just aren't working streaming-wise over Discord, so it's just better to do it this way. But explanations, if you feel that the explanations are easier if we actually talk over voice, just let me know. I just need to double check certain things to make sure that, again, this was done super quick, so I didn't double check certain things that I should have before I started streaming. Okay, awesome. All right, so everything is normal. All right, let's get started. So I'm going to introduce you, Apricot, to a state machine. So this state machine is so the reason why I'm going to introduce you to the state machine first is to get your head into the space of what's called separation of concerns in programming. And I think a state, and as well as event programming. And I think that this very simple version of a state machine is a great entrance place for learning how to create good code. Is the music too loud or is it fine? Because I could never tell from my side. Like, can you hear me over the music? Or is it distracting? There we go. Okay, I guess you can't hear me. I hear you. Okay, gotcha. All right. Okay, so that means it wasn't you I was talking to. Hello, other person who was in the... Gotcha. All right, so Apricot, can you hear me properly or no? Oh, you said that you can. Okay. All right, so this is a ton of issues that you're going to see over here. I'm going to have a ton of stuff on my screen, but I'm just going to move all of this stuff over. Okay. So the very first thing is I want to introduce you to the state machine. I think this is too distracting. At least it's distracting for me. Hold on a second. There we go. Okay, so let's take a look. I'm gonna just work on it really. This is just super quick, super dirty. Let's just make a new. This is still the same project that I had introduced you to in the private video, but I'm gonna just show you how to make a really dirty state machine. It's not my state machine. I'm gonna show you my version of it in a second. That it's basically taking it to the next level. State. So this is tutorial state machine. Okay. So now when you create a new script in Unity, it will automatically populate this for you, right? Which is nice. Most of the IDEs do that. So let's just work on a really simple, really dirty state machine. I call this Taro state machine because he introduces it, and you can find this. I should actually link that, but you could find this on his YouTube channel. So this is actually my introduction that got my head into understanding good programming patterns and separation of concerns. So that's why I'm going to share it with you. Hopefully it works for you. So first we do this. We go, we create an enum. So we can say, and this should look fairly familiar to you. So we go enum status foo, which is just one state, and bar, which is the other state, right? So enums, this is how you declare an enum. We could easily do this also if we wanted to get access to it from outside. And just to show you, like, we could do something like this. Var stat, tutorial status, and we can get it that way if we wanted to, and then we can get foo or bar or whatever we want. So like we can get access to it this way, right? This is something that, remember we talked about this in Godot where it's just written into the script itself. So just by typing the script's identifier here, its name, we can get access to things like this. Same thing with if we do something like, I think it's just public. Yeah, we can do it that way. There we go. So if we do something like this, we can just do tutorial state, and you see like we get access to it. Oops. We get access to it that way also, right? So these are things that are just like written into the script. All right, let's move on real quick. So first we created the enum. Then the next thing that we want is something that's going to store the current version or the current state of the script, right? So we go something like private or protected. I'll go into private and protected in a second, but private status, and actually let's name this current status. All right, this should look familiar to you because it's not too different from the Godot version that I believe I had shown you before. And then we can do something like this. I like to make these public. I think it's event action status, and then we can do on before. This is a event, all right? This is just this version of the event, and it needs to be. Now we could do this, but this is a bad thing. We don't want to do this, right? Because anything that subscribes to this, let's say we have multiple instances of this across the game. If one of these goes off, we don't know which one went off, right? Because anything that's subscribed to this action will hear every instance of this that went off. So we actually just want this to be a regular event. And then we just copy this. Oops. And this is going to be after. So now we've just made the beginning of our state machine. Again, this is the super easy version of it. We're not going to, for this project, we're not going to be using this. This is, again, just to show you how it works. The overall concept. I hope you're sticking with me. And I had said before, I think you missed it. If you're going to chat through the YouTube chat, that way you are in parity with what I'm saying, because last time we were out of parity and it was a little, I'm not sure if it was annoying for you, but it was annoying for me. Okay. All right, let's get into it. YouTube is crying to me that I'm not streaming at the right. I'm streaming at a lower bit rate. Next time, I need to reset stuff on this now that I'm streaming Unity. Anyway, so we go this, like this, public. We go void, state changed, or change state, whoops. All right, and we can go status. This should look familiar to you again. And then, so I like to do this, but you don't have to. Actually, I'm not going to do it. I'm going to explain it. I'm going to skip it because there might be times that you want to go into the same state, like you want to reinitialize the same state. So I'm not going to, I usually do, I'll just show it. I usually do this. Right? Just to make sure that because I usually don't want to go into this, but in most cases, people don't program the way I program. They have their own way, and it's perfectly, as long as you account for it when you're designing, you can just ignore that. I like to not have to worry about it. That's why I do that. But anyway, you do this. Oh, whoops. Switch. There we go. Godot is match, Unity is switch. You remember the switch statements. Match statements. And then we just pass in the status. And we do this. And let's just do that. And then we do this. And we do that. So now there is a default for this, which is that. Right? So basically, if it's not this and if it's not this, then we check if it's a we're going to assume it's the default and we just break out. But we can put whatever programming logic we want in here. Then a very important thing, we have to do this. All right? And then for this, we need to do camel case. We need to do on before. And then we put a question mark here. Right? This is called a null coalesce operator. So what this is doing, or an Elvis, But what this is doing is that it's saying if basically what it's saying internally is if this is empty, then we don't do anything with this, right? Whatever is on the left, if it's not a thing, if it doesn't have anything in it, or if it's a null or default, then we just don't do anything with it. And then over here we do invoke, and we pass in the status. Right? And then we do the same thing over here. But this time on after. And boom. Let me push this over so this is easier. Okay. And there you go. That's a state machine. This is the simplest version of a state machine you could ever imagine. And now over here you can just expand it and add as many states as you want to. So state, state 2, state 3, and you just need to put in whatever the situation is here. So now, how does this actually work, right? Like how, yeah, you can understand this part. Like you might have like a function over here called like public, or actually private func, right? And private void. There we go. Okay, and we could just easily pass this here. Oh, oops. Right, and we could do that. What's going on here? Cannot fall through. Oh, right. Okay, we have to make sure that we break out of this, because otherwise it's going to try to iterate through and it's going to throw a problem. Oops. So this right here will be called, but then you're saying, well, what is all of this? This is just like extra code. Well, actually, no, it's not. We could do this also. So let's introduce, I think it's easier to read if I do it over here. Okay, and we can do something like this. Right? It's going to throw us a problem because we need to pass in this. Okay, and now this knows that this matches. All right, because this is statically typed. C# is a statically typed language, which comes with its benefits. But one of the benefits is that it'll warn you when things don't match. Unlike with Godot, you kind of just have to know. But with this, it'll tell you, hey, your signature doesn't match, which is this part. Right? Like if I get rid of this again, you'll see that this doesn't. This is going to throw a problem. Okay. And so now, if we change the state, after we've run through this code is going to go off, which is then going to have this, which is subscribed to it over here, go off also. But then you're saying, well, that doesn't, what's the point of using an event in this way? Well, that's so let's do the way that we didn't want it, that I didn't want to show you before. Suggested not to do it before, but you could do it this way. So let me put it this way. Doing it this way is the equivalent of doing signal in Godot, right? Doing it this way goes well beyond what signals do in Godot. This would be like putting a signal inside of an auto load in Godot, right? So now, instead of just doing this, what we can do is we can actually pass in tutorial state machine as a second parameter. Okay, this is going to throw a problem. And then we can just go like this, and then over here, this is a little bit, this is reflection, but it's fine. It's not a heavy call. Tutorial. target, I guess. Okay, so now we can say, well, if target is equal to this, or not equal to this, we just return. Okay, but if it is, we can execute logic here. Capiche? We on the same page? What is this? Oh. Interesting. You following what I'm putting down, then, or no? You need me to do anything over again? What's going on? I just need to know if I lost you or not. So I'll bring it. So this part. Let's say we made a completely new script, right? So in C# I can just do this. Like I can just go over here, and then in other languages you can too. GScript you can't really do it, but in this you can. I can go over here and I can do something like and mono behavior, I guess. All right, we don't need to even do that, but whatever. Okay, and then I could do this. Remember I showed you before about that stuff, tutorial? So hold on, before I even do that. So you see how this is throwing an issue now, right? That's because this is in a completely different class. It doesn't actually know anything about this class. So in order to get it to know about that class, remember I showed you at the very onset, you could do something like this. And boom, you've just now adopted a definition from that class. That's it. And so now we can do something like this. So let's say that this is another mono behavior that is on the same game object, right? We can do something like this dot game object You see what I'm saying? And boom, now we've just locked this to being tied to this. Now you're going to see this have an issue because this class no longer has foo fun. But if we get rid of foo fun altogether, we don't really actually need this anymore. Right? We can do this instead. So let's say again, we've just added this class as a mono behavior on the same game object. This is just one example. There's many different ways to come at this. I'm just showing you the power of using events to get that interconnectivity, right? So in Unity, you can do something like this. And we're going to type in tutorial. Okay, there. So we can do something like that. Now these calls aren't bad in initialization, but it's not usually a thing that you want to do to put some call like this inside of an update function. You don't really, unless they changed how this works. The last time I used Unity, you don't make get component calls. In Godot, it doesn't matter. Get node is a cheap call. But in Unity, they don't like it when you do it this way. The better way to do it is to use an event. So since I already got this here, I don't need to cache it either, so I can keep that memory free. But what I can do is I can go obj dot on Well, actually, we don't even need to do this. I think we can do it this way. Well, let me do it this way so you can see one way to get it done. Like if this was without this static, we could do it this way, which is on, after. Interesting. It's not coming up. Oh, hold on. Maybe I just need to do this. Huh, weird. Well, you can just do it this way then. All right. And so now this is in communication with this. I guess if you don't do it, like if I get rid of static, let's try that. But this is a legitimate way of connecting to that using a global. So now let's get rid of this. Okay. And let's do get component tutorial state machine. Yep, there it is. So you can't do it through that. You have to do it that way. All right. And so we have a problem. What if we don't get a component? We don't want to throw an exception, so we can just, again, put in that null coalesce, I think. Nope, it doesn't let you. So for this, you can't actually put in the null coalesce. That sucks. So it's probably better to actually just, like, if you just want to go completely safe, to do something like this. Ah, that's the autocomplete. There we go. All right, and you can just do if obj return. There you go. All right, and that's a completely safe way of approaching this. And so now we have a connection, but you saw how easy it was to make that connection. And so that's the beauty of using events. So this is one kind of an event, and technically they're not called events. I mean, they are, but these are what are called delegates. All right, and delegates is one of those areas that confused me a bit at the very beginning. But you can create your own delegates. If forgive me while I type this. Probably shouldn't do this because I haven't done one in a delegate. I haven't created a delegate in a while, but some delegate. Is that how it is? Nope. I forget the syntax. I have to look it up. But it's like you can create your own. So this is basically action is like a default version of this that's built in already. And you can create your own delegate and then give it its own signature. And then from there on, just have that be your delegate. I just need to remember how to set this up. Give me a second. Again, it's been a very long time since I've used C#, almost a year, so I'm trying to like pull it from memory. Delegate void? No, it's not void. It's definitely not void. Nope. Wait, it picked that up, so it should be. Let's try this. Okay. And then we just put in the name of the delegate here. So some. Yeah, there we go. And here we can put in the signature. So status. Yeah, there we go. Okay, that's it. Autocomplete. Okay, so this isn't right. There's something wrong with this. But the point is that you can create the delegate, which is basically going to do the same thing as this. It's just tied to this class. Okay. So this is the state machine. I'm not seeing any. I'm not sure if are you responding over Discord? Oh, you are responding over Discord. Okay. So what did you say? I hear you properly. Can't type on YouTube. Would be too much of a hassle to sign in right now. Okay, gotcha. Okay. All right. That's fine. As long I'll keep Discord open so I can see when you have questions. If you have it, okay, so you don't know what reflection is. So in this case, we don't have to worry about it. There's something that you're probably already familiar with, which is duck typing, which is very close, which is close enough from Godot, right? Which is basically like if status is tutorial status. Okay, so before I do that, this is probably what you're used to inside of Godot, right? In Unity, you can add on to this by just doing something like new status, right? And so now, whatever this might have been, this will now take this version of it and then push it out as this. And so now you can manipulate this as if this was this. So where is this actually useful? This is useful for things like an inheritance. Like, let's say that, actually I did it sort of in other places. I don't want to try to remember where I did it before, but it's in this project somewhere where I have an object that is inheriting another object, but I store that object as its abstract inheritance type. So what I do is I use is to check if it is the type that I care about, not its inheriting, not its predecessor. I care about like whatever it could possibly be at a lower level. And then I have it push out that lower level version of it. That makes sense. And then I can manipulate that lower level version. I can get access to that lower level version's information. All right. So this is now a few things that I've introduced you to in C#. One is setting up enumerators. The next is events. The next is the state machine. Then also how to call events and how to connect to events, right, from other classes. And then how signatures need to match, as well as the Unity or C# variation to duck typing. Right? So let's say instead of this, I could do something like this. You get what I'm saying? And instead that, we can do something like that. And we can get, so let's say that this wasn't inheriting this. Let's say this was inheriting, what's another mono behavior I have somewhere? Economic simulation. Okay, so let's say this is economy simulation, right? And this is being passed as economy simulation. You get it now? So I don't care about the economy simulation in this case. I care about what it becomes, which is the tutorial state machine. And I want to manipulate the tutorial state machine's data, which I won't have access to if it's just going to be the economy simulation. And this allows me now to keep this generic. So I can do something like this, economy simulation. There we go. All right, and so now I can do this and get the same result. It wouldn't have made a difference in that case, but there's certain cases where you want to do that. That's duck typing. That's as close as I can get to like what Godot has for duck typing. Sorry, for reflection. Um, okay. So where do you feel like? Do you feel like I can move on, or you feel like you need me to hit anything in particular again here? This is the opportunity, man. Move on as in you do understand it, so it's fine, or move on you don't understand it, but you just want me to go move on from this. I need to know if you understand, basically. If there's areas you don't understand, I guess that's fine. You can always watch this part again. But if if it's like the whole thing you don't understand, then I need to at least try to get you in line to move in that direction. Okay, gotcha. All right. Um. Okay. All right. So this is fine. Um. This is absolutely fine. So there we go. Okay. So this is a state machine. This is the simplest form of the state machine. I will share with you the link to Taro Dev. He probably does a way better job of explaining it than I can, and hopefully, you'll get what I fail to be able to share with you. Um, let's move to the more complicated version of this. Uh, this is the state machine that we're going to actually be using in this project. Let's close this. Yeah, if you see that I'm like, if you think that I'm going too fast, I'm doing this so you can see it. So just let me know, and I will stop at that point and then explain it. You know, I don't know if you don't know. In other words. Okay, so let's look at the state machine. So the state machine that we're going to be using in this project has two CS files. It has a state and it has state machine. So let's look at the state first. Okay, already you're seeing some events, right? And each state has these. Now, all this state is doing, this is the basic concept of setting up an API. Oh, oops. Yeah, this is the basic concept of setting up an API, right? So the idea behind this is, first, let's break this down. Let's break the class down. And I actually left it this way because I wanted to use the AI. I have an AI on this, so I'm going to actually use the AI, and the AI is going to parse what each one of these are doing, and then as it's parsing it, I'm going to read it out so you can explain it. AI does a pretty good job of explaining what these things are. It doesn't explain these parts though, so I'll explain it for you. First, we have the events that I've gone over, and if you notice, each event, these are just passing back the state that we are entering and exiting, right? Which is the same state. It's going to always be this state. It's a bit weird, but again, this is what reflection is. This is a constructor in Unity. So this is basically, if I'm going to do something like this, right? This is basically what this is. I'm calling this method, and it'll create a new state with this state name. Okay, so basically the state name should be pretty self-explanatory. Now I have pieces, which is pretty good at writing. Is it going to do it? Comment. I think I need to launch. Yeah, there we go. Close that. Okay, I think it's running. Comment. Is it running? Oh. It's all the way over here. Gotta move stuff. Hold on. I guess it's not working. I don't know. Yeah, I think... Oh, there it is. Okay. So, I just clicked state, right? So, it's a constructor. So, let's actually see what the AI writes for it. There you go. So, state initializes the instance of this. So, if I actually hover this now, it'll read out. This right here is just pushing this information, the tooltip information. So, state.state, string name. It takes in state state name as string, initializes a new state of the state class with the specified state name. Pretty self-explanatory, I hope. Then we have this comment. Okay. There we go. Let's see what it says. Okay. So state.add connection adds a connection to the state associated with the functionality to be executed when entering or exiting the state. Again, the AI does a pretty good job of explaining things here. It doesn't explain the rest for some reason in the tooltip, but basically in the actual thing it does. It says if a boolean indicating, so basically this on enter is going to determine whether or not we are connecting this functionality to when we enter the state. If it's false, then we're connecting it when we exit the state. Add process. So again, this state machine's design, the architecture of this is basically one level up from the previous one that you saw. That was super simple. This is the one that we're using for this project, though. Add process is basically similar to the other one, except this is happening. This is going to be called every frame, right? Not add process, but this part down here, the process call, which is going to run on state process, which is connected to over here. I'm going to give you a second to catch up on that. I'm going to pause right there. Let me know if you need me to go back over anything, or if you've gotten what I put down. Well, the way that I'm coding this is that this is talking about separation of concerns, right? And keeping the data on one specific thing. So, yes, to answer the first part, like I said, this part over here is being AI generated. I intentionally did that so I could have two shots at explaining this to you. I would have normally done this ahead of time, but I wanted to make sure that I said it, and then basically the next best thing that I could get to a substitute explainer, I said it in their own way also. So because I don't know if I'm explaining it badly, so I'm just trying to get as many versions of the explanation to say that it's basically saying the same. I just want to make sure that you understand it at the end of the day. All right. Okay. All right. So the rest of your question. Yes, the AI is explaining what that specific piece of the code is doing. It does have some kind of understanding of the context of the code of this script, by and large. But it wouldn't know more than what's happening on this script. And this is by design, right? There was actually a video that came out today that they were talking about which way is the best way to code. If it's better to break your code into smaller pieces, or if it's better to have one very gigantic, huge, enormous script that has all of your code. And the answer is whichever way is easier for you. If you're a solo dev, if you're working with someone else, the best thing to do is to break your code apart. You don't have to go completely to, like, if you're going to jump, this is the jump script. If you're going to walk, this is the walk script. There's a middle ground, right? If you have the player script, it should be handling things that the player needs. But if you realize that you want different, let's say it's a multiplayer game and there's different classes and they are going to act differently, then you might want to have the walking script broken out if it's going to change because of something else that's going to happen. Like if your class changes, suddenly you're walking a little bit like this or whatever, right? Whatever makes sense for your project. So in this case, this is me showing you the beginning of how to set something like that up, which is to first recognize separation of concerns. So in order to do that, what we do is we use encapsulation. Encapsulation, basically, we take one function and we lock it into the one thing that it's supposed to do. In this case, we have add process, right? We don't have a bunch of different things that are doing add process, or we're not connecting. Like I could easily put add process into add connection, extend this out to something else, like to include a Boolean for if it's a process or not. And then we could put this code inside of it and set, and now add connection is doing a bunch of stuff. But we don't do that in this. What we do is we just break it out, and each one of these has its own call. Actually, I think I missed a call. Add process, add fixed process, add late oh no, we did it right. Okay. So when we do this, what I'm doing is that I'm disconnecting any function. If this functionality is already connected to this, then I'm disconnecting it, and then I'm connecting this functionality back to it. We do this in case there's some type of difference that might not be getting tracked internally, as well as to prevent any warnings or errors from trying to connect the same functionality twice. And if, like, let's say we have like a movement script and you press forward, if the functionality is attached twice to this, you'll get double movement effectively, right? And we don't want that. So we want to try to remove it in case it's already there. If it's not, this doesn't really do anything. It doesn't hurt to have it there, in other words. Okay, so basically this is just, you've seen it done when I did the first state machine, which is how to add a connection to these actions. Right? And then when we remove a connection, usually in this case, I just chose to remove everything that could possibly match that connection. I didn't care. It doesn't hurt to do this. So I just did it like think of it kind of like just spamming remove functionality, right? Like I don't care if it has it or not, I'm just going to try to remove it. This is what's called, internally what C# is handling here is called a pass by statement. So if there's nothing here, it'll just pass by this. But if there is, it'll do something. Okay, let's put in the rest of the AI's definitions for this and go through it. All right, so this adds a fixed process. And it says, yeah, like I said, this is delegate. If the action already exists, it will be removed to ensure no duplicates. I'm hoping that the AI explanation is helping. And you don't have to stay in 100% parity with me. That's the reason why I was trying to get you to use the YouTube version, because you can pause the YouTube version or just go back and see where I was and just throw your questions at me over Discord, I guess. Right? You don't have to keep 100% at my exact pace, which is much better than doing a stream over Discord to you and then having to bounce back and forth. So if you don't understand something, feel free to rewind. Let's do remove connection. Okay. Remove the specified functionality from the state. The action to be removed. So this is basically describing this functionality. This is the action to be removed. There we go. It doesn't really do a good job with the syntax for the coding. It's weird. Okay. All right. So now let's explain this stuff. Actually, let me check Discord to see if you have any questions. Are those functions all just adding and removing connections? Is it a toggle? Okay. So yes, like I said, this is an API situation. So we're just setting up the API for accessing the state and its contents, right? So primarily, this is its content. The stuff over here at the top. So on state entered, on state exited, these are all the content. Think of them kind of like a list that contains all of the data that the state will have. The state right now only has the API for accessing this stuff, and it also has the name, which we create when we create the new state, because that's part of the constructor. So think of it kind of like you buy a blackboard and then you name the blackboard Lucy. So now the blackboard is named Lucy. But it's just a blackboard, it doesn't have anything on it. You get what I'm saying? So these functions over here are effectively writing stuff to Lucy. So now after we've done setting all of these things, Lucy will have a bunch of functionality it can do when we activate this state. Does that make sense? Let me move to your next question. Is it a toggle? No, ideally you shouldn't want to toggle these because these are states, right? So like if you're in the crouching state, then the toggle is when you come in and out of the state, right? But you're not actually disconnecting anything. The only thing you should be doing is adding the connection. You shouldn't really be disconnecting very often, in my opinion. It's mostly the state machine itself will handle that. Remember, this is just the state. So again, this is like the blackboard. So we're just writing to the blackboard. It's when you wouldn't want to erase anything from the blackboard until you're done with the blackboard, right? But in this case, instead of thinking about it that we're done with the blackboard, think that we have as many blackboards as we need, right? And instead of erasing the stuff on the blackboard, we just move the blackboard out of the way and grab the next blackboard. Does that make sense? So, like, for example, when we first make the state, we can add at runtime any amount of connections that we want to the state, right? And that's kind of like writing functionality to this state. We don't need to remove that functionality from the state. All right, we're just writing to the state. Look at this for what it is. Don't look at this for what you think it's going to be. I'm going to show you the state machine itself. This is just the state. Right? So don't think about this in the context of how is this transitioning. Just think of this as in the context of what is this doing. If that makes sense. So again, all this is we're writing to the blackboard. You know, we can remove stuff from the blackboard if we need to, but generally we shouldn't need to. Okay? All right. So now let's get to the part where stuff is actually happening now inside of the state. We have enter, we have exit, we have process, we have fixed process, and we have late process, right? And this might be the part that clarifies the line of questioning that you just had. When we enter the state, we're going to run on state entered, which anything that connected to this part of the state when we did add connection is now going to run. And then when we exit, we're going to run on state exit. So if there's anything that's connected to on state exit, it'll run here. We're never removing anything from the state, right? We're just running the different functionalities by calling these invokes. How's that sounding? I'm sorry if this is coming off. Let me actually push the AI's explanation and see if it does a better job than I did. Okay, so invokes on state entered event if it is not null, passing the current instance as a parameter. Right. So now, and then exits is doing that. So now process, this is a little bit more complicated, right? But it's following the same rules as this. Process is happening every frame, fixed process every physics frame, and late process at the end of a frame, right? So this process is being called elsewhere. If you notice, this is not a mono behavior. This is just an object, right? And now we're about to get into the state machine proper, so you can see how that's connecting. But that's why I said this is a little bit more tricky. But let's get the comment in. I was actually talking to a friend about this. I said, the beautiful part about AI is that nobody ever has a reason anymore to not do proper documentation. Like, oh man. If I actually see that you just don't have documentation, I know that you have to have a good reason. Okay. It does a really good job of grabbing context. All right, let me show the actual state machine now. Okay. So now this is the state machine, and the state machine contains a dictionary of all of the states that it currently has. Right? And you'll notice it's a mono behavior, which means that this is a component that we put on something. I'm going to go all the way to the bottom so you can see the part that you were getting confused with, like how it's handling that part, which is right here. These are built-in Unity features, right? Fixed update, late update, and we're just calling whatever the active states is, processes, right? From these. That's it. Right? And if we go back to the state, that's this stuff down here. Okay, flipping between the two. This is the state. This is the state machine. So now what's the benefit? The benefit is we only run update loops now on the thing that's actively, on the processes that are actively in that state, right? Instead of, because in typical design, a new developer will just start throwing things in update inside of different mono behaviors. In this case, we've batched all of those calls and lock them out if we're not in the state, which is saving a lot of process time. Right? So we are only concerned about the active state. We don't care about all of the other states processes, so we don't need to do stuff like if we're not, like if foo state does not equal state I want, right? We don't have to do return. We don't have to do that all over the place. Instead, whatever the active state is, it's only going to run the stuff that we did add connection to, or add the connect process to, right? Which is this. Add process. You get it now? Okay, so add fixed process, you're reading it correctly. Basically, we do that in order to ensure that we don't duplicate the functionality. Because the functionality might already be there. So we want to remove it, and then we add it back in case it was already there. Let's see what else. Okay, understood. Correct. That's it. We don't want to have a duplicate there because, again, if you like press, let's say you have a WASD control. When you press W, if that state is there twice, and let's say like you're supposed to take 1 step forward if you press W, instead you'll take 2 steps forward because you never disconnected the first functionality. It'll call the same functionality twice. You get it? Awesome. Okay. Whew. All right, let's go back to the state machine. So, well, actually, let's look at state for a second. So you'll notice, again, let's just stick to one because the rest of them are all doing the same thing. So process is happening on the process loop. And the process loop that it's happening in is over here in the state machine under update. Right? So we're actually using this to manage any process loops that could be happening inside of the active state. And now this part should start looking sort of familiar to you. Right? We have change state here. We put in the name of the state that we want to change to. And then we handle the transition to that state. So the first thing that we try to do is we do try get state, which will check the dictionary over here. This is try get state over here. Notice that we split. This is again separation of concerns and encapsulation. Actually, we could just do this. Can we? Yeah, we can do this. We can make this code a little bit cleaner. There we go. So, basically, we'll try to get this state, and if we don't have it, then we'll just return with whatever the current state is instead of changing the state. Right? Otherwise, we'll attempt to change a state if we found a state. This is going to pass out. So let's break this down. Right? This is what's called a pass by statement. The first part is try get. Try get is going to return a type of Boolean. That's a true or false statement. Then we have this, which is the object state, right? That we just went over, the one that with all of the other stuff happening in there. And then we have the name over here of the state that we're querying. So then we go into states, which is a dictionary over here. And we try, this is a built-in function inside of C# for dictionaries. We do try get value. We pass in a key identifier for that dictionary. And then we grab this variable, pass it in here, and this will return this same variable. Back here. If this is true, then that means by definition, this state, we found something. All right? In other words, that key existed and we got something from that key. Then we have this on before state changed, and we have on after state changed. Right? So now if something cares only about the state machine's changing state, we can actually connect to the state machine and just get this. But we could also do the same thing with the state itself. If something only cares about if the state is entered, that specific state is entered or exited, then we can just connect to these on the state itself. Right? And I've showed you how to connect it. You've seen it multiple times over here. Connection and disconnection. That's how you connect to delegates. Okay. And then over here, you're going to see the exit call on the state, the new active state, or sorry, the old state, the state that we're phasing out. And then this enter on the new state down here. Right, this is just checking to see if the state is null or something, because if it's null, we don't want to try to call exit on it, because there's no state to call exit on. And that's it. That's effectively the state. The rest of these are just helpers. Like, we get to check if the state, if the current state is this state, or if whatever state we passed in is the current state. Get last state, so we get the state that we were before the current state if one is there. And then we can get a list of all of the states in an array on the state machine. And then we can use this to create empty states. We can just pass in a string, and then we can just create new states this way if we want to. We don't have to do it this way either. Right? This is really just meant for like initialization, where we can just populate the entire machine with all of those states. Okay. Now there's other ways. There's another way that I would like to have implemented this, but I haven't, which is I didn't do it that way because I didn't want to make it too complicated for you when I was explaining it, which is to introduce generics to states. So I could easily do something like this with a generic. I'm not going to go too deep into this. Right? And so now what this would allow me to do is I can set the type that T is. And so now instead of using a string, I could use something like this. And now I can store type T as a state name, which this is then going to allow me to store a more static type in this state, right? So I can in turn store like an enumerator instead of using a string. right? Because T could be something like, let's do this. So T could be something like, hold on, let's do this also here. Where T is, what was it called? I think it was called tutorial. Yeah. Right? And so now we can store this enumerator inside of the state type that we're creating. And then manipulate the enumerator instead of manipulating this. So now we can do something like oh yeah, I said I wasn't going to go too deep into this, but let's just finish this so I could just show it to you. Because you're going to see this show up in the code in different places. Right? And so now we can do something like this. Okay, there we go. Okay, that's a state machine. What do you think? If you at least got like 20% of it, I think that's good. I think that's a victory. It means that, because it means that you're moving in the right direction as far as just your eyes being able to get your brain to say, ah, okay, I kind of can put these references together. Sure. Well, we can actually just do this. Is that better for you? Okay. So this isn't like copy paste code. You're gonna, when we go over Git, you're gonna see the code directly anyway. The point of this is that I'm trying to explain to you some of the more intermediate concepts of programming in C#. So, well, actually, I would probably say this is like late beginner. Once you understand most of this, you're pretty much inside of, like, you're at least at the end of your beginner stages. You know what I mean? And then when you get the whole process of going through intermediate is just getting really comfortable with this stuff. Oh, cool! I didn't know it did that. Cool beans. Okay. Do you have any questions, or you feel like there's anything that I need to clarify for you? Like, this is actually, this would probably be a very good time to go back to the other one. Well, hold on. You said that you don't want to look at the other one, but the other one is like a simplified version of this. You want me to go back to the simplified version? Awesome. Okay. Like, give me a number, like 1 to 5. How comfortable do you feel with yourself, and just like coming to grips with how this process works? Oh, okay. Okay. Awesome. All right. So I'm going to, yeah, start is working, add state. All right. So this is just like basic API setup. So now let's actually get into, well, how do you feel? You feel like I can move on from this? Because now I'm going to get into some of the economy stuff that I had intended to work on. Like, that is going to be some pretty crazy code. Okay. All right. Let's do that then. Give me a sec. Oof, 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 oof. So you're gonna see the learning process with me, because all of this stuff is just finished. Actually, yeah. You know what? Let's finalize something here first. I'm going to go back to the state class. I'm going to change this. So we're going to change this from this to a generic, because you're going to see a ton of generic. So might as well you see me do it here first and see why things are implemented that way. Okay. Oh. Weird. Give me a second. Something broke somewhere. Okay, let's start with this. Okay, so it doesn't let you do that in the constructor. Gotcha. There we go. Okay, there we go. So this is just how you set up a generic. Now this should take this in. I want to see how this call works now. I'm not sure about it. Okay, I see. It has a built-in, so that's why it was giving me a problem. It's built into it, I think. Let's find out. Tutorial state machine status. And we can go tutorial. Does that work? Yeah, it does. Awesome. And that's the call to make a new state. Okay, awesome. Alright, so now we have to go back up to the part where we construct new states. Where the built-in... You can create a new state like you just saw on your own, if you want to. But there's a built-in constructor for it, which is this. Right, and we're going to pass this in over here. Basically a lot of these, putting these generics everywhere. Okay. Just make sure we have them, the states already set. Okay, that should be it. Okay. Dictionary is already set up. So this is not a string, this would be... There we go. And then when we do change state, instead of a string, oops, we're doing T. Yep, there we go. There we go. Name is... We'll figure that out in a second. Let's go back up here. T. Hope you're kind of seeing, it's not really complicated stuff, you know? So the beauty of doing this is we could always just make this string, right, if we wanted to, right? But we're going to keep it generic T because we don't know what's... Basically, we don't know what's going to be passed in as a type that the state machine is going to try to identify with. So we actually can just do that at runtime as we need. And as I've shown you 3 or 4 times already, you can pretty much just put in whatever you want. As an enum, and is what I'm in my mind. I want it to be an enum, so it's up to you. However, I think enums are just safer. Okay, and so now we have to make sure that the active state dot name. What is name? That's crazy. Alright, let's fix this first. Keep doing the Godot way. It's weird. Can you do that? Ah. Interesting. Interesting. Give me 1 sec. Ah, there it is. Okay. I ran into something I did not expect to run into. So you can't compare generics using that. I think I probably have to use like type of. Let me see. Let's check. Maybe if I cast them. Nope. To be fair, I've never tried doing a direct comparison of generics like this. This is a learning experience, so let's learn. Okay, dismiss. There we go. Let's see if that works. Oops. There we go. Okay, now let's see if this works. Oh, you gotta use equals. So you're checking default and dot equals. Gotcha. I forgot about equals, I'll be honest. I completely forgot about. This is a call that you can use for comparisons like this. I'm not sure if it's using reflection though, which is probably bad. Unlike Godot, Unity doesn't have a built-in direct access to their like their documentation. So I'd have to like Google if this is the case. But anyway, this is good to know. So we can actually just get rid of this altogether. This part. There we go. I need to find out what's going on there in a second, but for right now, where's the other one? I think I already did it. This is it right here. Yeah, I think that was it. Alright, so let's find out why this is crying. This is saying cannot convert. It's trying to convert something to something else. What is it trying to do? Preloaded states is what? Oh, okay, gotcha. Oh no. Darn it. Darn it, darn it, darn it. Ran into a very annoying issue. So here's the thing with generics. They don't display on the inspector in Unity. So you can get them to display easily in Godot, but not in Unity. So what does that mean? So this is supposed to be that I can create these states. I can create these states from the inspector, but you can only do that using strings. Right? And technically I could lock in a specific enum, but the entire point of the generic is that we don't know what enum we're going to be getting. So that means that we need to get rid of this altogether, because I'm not going to worry about the headache of creating that. That's a different situation. So let's actually, we can get rid of this. Prep states. What are prep states? Prep states is just that. Okay. Yeah, we can get rid of the whole thing. Okay, there we go. So let me look at the creation process down here. Let's try doing let's try creating it real quick just to see what happens. So let's just do like a public void just want to see how the code flows. So we want to do var machine. It's going to be equal to populate. Or actually, let's make it simple. Var states is going to be equal to state machine, and let's actually do this. Enum, some states, 1, 2, and so on. Okay. Some states. Is it create? Yeah, create empty states. And so first it wants us to create the machine. So var machine is going to be equal to add component. Okay, there. So this was just get the game object, add that to it. And then from here, we can put in I guess some states. And it also wants the machine. And it wants us to pass in some states. Right? What is it saying? Non-generic method cannot be used. Does it want us to pass that in? What is it looking for? Create empty states. Oh. It's a little bit confusing, but I think what it wants is this. It's a little confusing. Is that what it wants? Oh no, that's what it's returning. Oh, it doesn't have anything. Why was it asking me for... What is it asking me for? It says no overload for the method empty states. It takes 2 arguments. I did. This is the first argument. This is the second. All right, let's... Maybe it's a Unity thing I forgot. New... Is that how you do... I forgot how to do arrays. Huh. 1 second. Okay, sorry. Sorry about that. All right. So yeah, I actually forgot how to set up an array in Unity. Hold on. Hey, It's been a very long time. Give me 1 second. That's how you set up an array in Godot. In Unity, it's different. I think you have to... Let me check. So I think it is var array is going to be... Does it autocomplete do anything? No. Okay. So... I legit forgot how to instance an array. I've done it before, so where is it? I mean, this is one version of it, right? Array.length t array. So we okay, gotcha. So we go. So this is an array of some states, and then we can go r, and then we go. I think like that. Is that how that works? It's giving me a warning here. Feature expression not available. Can I do this? Does it let me? I don't think it does. Dot to or no. This is not Godot. You cannot do that. Godot allows you to get access to enums like that. Can I just do this? Does that work? Nope. Okay. Hey, we found one thing that Godot is better at handling in a more human readable way. Or rather, I should say GD script. And then R. It's not reading the first part. State machine, T machine. Oh, that's why. No, what am I looking at? Create empty states. Create empty states. We are returning the state as an array. And then we pass that in. But we never actually set this. That's, I think, what the problem is. And it's crying that I never set that. So I think we can do some states. Is that gonna work? No, it's still saying no overload. Show potential fixes. Oop. T1, T2. Huh, weird. Weird. We have two issues here. The collection expression is not available in C#9. Please use language version 12 or greater. Gotcha. This is not the correct way of setting this up. I thought it was, but it's not. Can we do that? No. I think we have to do something else. Maybe it's r.add range. And then we do that. And I think we need to something like, I think it's like 0. Is that what it is? It's like something. It's like super foggy. I just need to Google. Let's do that. Where is my Explorer? There it is. Scripting API, a new array. Oh, I was close. Okay, gotcha. I was getting closer. New some states. There we go. I was getting slowly but surely closer. So we can get rid of this. And I think we can get rid of this. And get rid of this. And this needs to change. There we go. Technically, we shouldn't have to do that, but because we're doing this situation where I'm just testing it out, no overload. It's still going nuts about something with an overload missing. It says it's supposed to take in 2 arguments. It's accepting both arguments. Maybe I'd need to add... What did I just do? Oh! Uh-oh. Oh. Gotcha. There we go. I'm dumb. I was reading this part when I meant to do this part. Okay, there you go. So, that's it. Okay. So now, at least I relearned how to do an array in Unity. So now then we go machine, or actually we do state machine dot populate where is it? State machine dot populate machine. That should do it. I don't know why this is not coming up. Machine does not contain populate machine. It's right here. It's I'm literally looking at it. What do you mean it don't? I'm literally looking at it, bro. And this I shouldn't need to do this. Let's get rid of that. I think that's just being extra. We don't even need this technically. Okay, there we go. I'm hoping like it's coming through. Like if you're using GDScript ever, you'd know variants and how they work and stuff like that. But now I'm trying to figure out why this is not. Did I type? Is it a typo? Just copy paste. Nope, it's not a typo. It has decided that it doesn't want to work. You know what? Let's actually just take this whole thing here. And let's open up the other thing, the tutorial state. And let's just add it here. Okay. Okay, I see. So now it's easier to see because we're outside of the script. So this is just looking for some states. That's it. It's actually sending me back proper information when I was outside of the state. So this is basically it. So now this will actually, so this process is a little bit lengthy. I might rework this. But yeah, essentially we created a state machine by adding it, because it's a mono behavior, we just added it to whatever game object we wanted. Then we create the array here. We needed to populate this array, so let's do that. Some foo. Is this gonna work? No. Okay, I get it. I remember now. So we need to actually do this with an array, right? And then we can do this, or like that. But I think we could also do this. Add range. And now we can do some states. It's a little bit convoluted, but it is what it is. We need to put this inside. Ooh. Oh, that's annoying. Okay, we can't do it that way. You can't just create a array like that. Apparently, we have to do it this way. Hold on, can we do this? This is just, you know, I'm still learning how things like to be set up here. I don't think we can. Can we get access to it that way? Or how about this? No, we can't. So you really just can't access enums the same way like you can in Godot. Like, you can't treat these like dictionaries or basically like collections, which kind of sucks. Alright, so yeah, the only way that I can see doing it is something like that. and then like that, and then we pass in this. I was looking for every cheap way to get this done. And then we just pass it in, and then it'll create, and it'll, so we've created the state machine here, and then we populate the state machine here. All we're doing here is just passing in different stuff. All right, as I get more familiarized with C#, I'm going to definitely hitting this API again, but for now, it'll work, and that's what matters. So let's go over really quick the setting up process, because I might have, in my learning phase, not have expressed to you exactly how, what was happening. So you need to instance, or need to create a new instance of an array, and the array is of type SumStates. And you have to also establish how large that array is. And then we stored it inside of this, right? And that's what allowed us 0, 1, 2, 3 are the 3 possible elements inside of that array. Okay. All right, so we know what the API looks like. I don't like it, I'll be honest. I'm going to definitely hit it, I think, at some point. But, yeah, that's it. Okay. Yeah, that was it. So, that's the cost of sticking with enums, I guess. All right, let's get into the economics. So let's get into the economic simulator part. Let's close the state machine up. States. Player controller close. Damage. I guess. But yeah. Okay. So, yeah. I'm on like version 5 of iterating through the different ways of approaching the economic simulator. A lot of this stuff is probably going to have to be deleted. Well, definitely have to be deleted. I was just messing with different ways, and I didn't like some of these ways. This way is the last way I don't like it. And I'm not going to, I mean, unless you want me to, I don't think I'm going to break down exactly the approach that I'm going to go into right now. But I am just going to do it. But I have a picture in my head of what I want this to be like. I was playing Stellaris for a little to try to like get a feel for different games' approach to economics, and it was pretty inspirational. So I'm gonna give this a whirl. Let me see if you're communicating on Discord. Give me 1 sec. Sorry about that. Yep. Okay. Good. Okay, so one of the things that I like to do when I'm working on just like new code, and I don't care like what it looks like, is I just create classes within classes, right? Because I'm just too lazy to create a whole new script, because I don't know if I'm just going to turn around and delete that script later on. So before I go ahead and start creating whole new scripts every time, I just start creating classes all inside of the same script. So you're going to see, for example, this is the market script. And then if I scroll down, you're going to see internal classes sometimes like this, and then you're going to see like just external extra classes, as this is just me very quickly trying to speed run to my next iteration. Right, so hold on. So I'll be right back. I have to take care of something. Give me like 3 minutes and I'll be right back. Okay, back. Sorry about that. Okay. So there's a couple of things happening here before I start moving forward. I want you to tell me if you want me to explain a little bit about them, right? First thing is in interfaces. Basically, I told you a little bit about interfaces before. Generally in C Sharp, and you're gonna notice, sorry, sort of out of breath. You're gonna notice when people use interfaces by the I in front of the class. Right? So you want me to explain a little bit more about what interfaces are, or move forward? It looks like there's someone else in the chat, or sorry, in YouTube also, so I'm assuming... Ah, okay. Alright. So I think then if you're not... if you're done, then you're done. How do you feel, though, about the whole thing? Is it... how much would you say stuck? And do you feel... Well, actually, let me ask it this way. Do you feel this was helpful at all? Or this approach to... Where... Yeah. Gotcha. How are you finding Unity Learn? Do you think it's a good path that you're going down, or you feel like just watching YouTube videos would have been better? Awesome. Alright, so you don't feel like this was beneficial to you at all then? It's just abstract information. Alright, well, I mean, I tried. I think it comes down to that once you get a little bit deeper into it, I think this stuff would probably help you once you get through the beginner phase and get into the I'm stuck in tutorial hell mode. And this would probably be useful to you just to get like an idea of approaches to hard problems, and then just dealing with them on your own instead of going and discarding something and then going back into tutorials and figuring out stuff. Tutorials are great, but you know, yeah, there's different approaches. I see. Okay. Well, I mean, part of it when if you do rewatch it, part of it is also just it's not so much how I'm coming to my well, let me rephrase it. It's not so much what I'm doing exactly to come to this fixing the problems that or what I'm doing wrong. It's how I'm debugging that's important that I'm trying to share with you. Right? Like looking at what's being offered and then just keep messing with stuff and building that knowledge of, hey, it's probably throwing me it's probably throwing me the wrong information because I'm doing stuff within the class on a static. So instead I just pulled out of it and put it into a different class, and suddenly it gave me accurate information so that I could debug it. You get what I mean? Like stuff like that is stuff you would know through experience is what I'm trying to share. Anyway, yeah, take care, man. I'm gonna call it also, unless there's another person that was here. I'm not sure. I don't want to end it if they were gaining anything from this. So I'm not sure. They're not chatting, so I'm going to assume that they were probably like watching earlier parts in the video or something. I don't know. Okay. I'm gonna call it here, man. Thanks for your time. I think probably by the end of this week, I'm going to get to I'm going to finish the economy and get into the next part. All right, man.